Hello, welcome back everybody. As you might have guessed from the title of this video, or I guess the title's down there, we're going to start a new project, a new CAD project. We're going to be 3D printing little fidget spinners here, okay? If you've seen these things before, you take them, you spin them around in circles here, and they're fun little fidget toys. Yeah, they're fun little school projects. Some teachers actually hate these things. They annoy them in class, but I think they're pretty cool. Keeps kids rather calm and lets them kind of play with stuff. So why don't we make them here, design our own, and then we can 3D print them all custom. So there's a few things we're going to need. One is access to a 3D printer, obviously. I'm using a MakerBot Replicator Plus is what I'm using. So that's going to be my examples as I go through and print and show you how that works. The next thing that you're going to need are these. Okay, this right here, if you can't really see, is a skateboard bearing. All right, you can just look up skateboard bearings. They're pretty standard. This is a 608ZZ. Now the Z just stands for the enclosure here. Notice in a bearing you do have this inner part. Okay, so you have this inner ring. All right, and inside this inner ring and an outer ring, between the two you have a bunch of little metal balls. Okay, it's a ball bearing, and this has a little piece of metal on in the center here. This is the shielding. So if you were to pop off this shielding, you would actually see all the little balls rolling against each other, and they roll inside of a little groove in between the inner and outer bearing surface. So these are pretty neat. You can pick these up all different kinds of prices from Amazon or your local skate shop or wherever you want to buy them from. They're pretty common. There are many different types of these as well. So you can go ahead and start going off onto ceramic bearings, different kind of whether you want exposed ball bearings or not. I don't really suggest using those, but you can go in and get the standard reds, which are higher quality ones. These are just Amazon special ones that I picked up because they were pretty cheap. And they're perfect for our project here. The next thing that you're going to need is some cheap counterweights. Now, a lot of these, if you get a set of skateboard bearings, then you'll have 1 for the center and 3 for the outside. So you can actually do this project with just skateboard bearings in order to save money, because ideally we're going to be selling these in school right out of our school store. So we're going to be using different counterweights. Our counterweight is just going to be a simple hex nut. And you can kind of see this is a 1/2 inch hex nut. I've got 3/8 hex nuts that we've used before too, and just as long as they're all the same size, this seems to work really well. We've used rod in the past, okay, just a standard metal rod that we've cut off with a hacksaw. But the problem is the width is going to be slightly varied as you use a hacksaw to cut that off. It's really hard to get those surfaces perfect and get those weights exactly the same. So if you use something standard like a nut, the balance on your spinner is going to be better. The whole point of our spinners, in order to make them spin, is they need to be balanced. Okay, they have to have good radial balance. Okay, meaning in all directions. So here we have our 3 counterweights, and they are spread out. All right, they are posed at a 120 degrees, right? Because we're using radial balance. So if we divide our 360 circled by 3, you're going to get an offset of 120 degrees. And let's see if you can get a good look at this. And this one, our logo is a zebra. And you can kind of see our MBHS on there, and there is our zebra cutout as well. And we're not going to get too advanced in how to do this, but you can kind of see this shape here on this one is a little more circular, so it's kind of easier to see. A lot of times we have a hard time visualizing that this is actually built off of a circle until you start spinning it, and then you can actually notice that they're just circles. So we're building this off of circles, all right? What else do you need to know? Well, we need to know the sizes of everything, all right? I have a good, well, not good, but a decent set of dial calipers. This will work. You could also use, to lesser extent, a standard ruler. Anytime we build anything practical in the world, we're most likely going to have to go through the metric system, the decimal inch and fractional inches. We're going to be just using, if this is a 1/2 inch nut, standard skateboard bearing has standard sizes that you get when you buy them. They tell you that we have a 22 millimeter diameter here on the outside. You have a 7 millimeter hole, I think, and then 8 millimeters thick, if I got that right. I actually don't, I haven't actually measured it in a little while, and I don't have my notes in front of me. Yeah. So you've got 7 millimeters thick. You have an 8 millimeter hole. And we have a 22 millimeter outside diameter. All right, so 8 on the inside, 22 on the outside, and 7 millimeters thick. All right. What else do you need to know? Well, how big do you make this? Now, a lot of times when we see these out, they're always one standard size, but why is it that size? Well, you can use something as simple as a ruler to figure out how big yours should be. Everybody's hand size is different, so you should customize this to your own hand size. Now, the reason is you want it as big as possible because then you can get the counterweights further away from the center or the central axis, okay? So that central axis, all right, and you have inertia, right? So you have weights that are so far away, and you're talking about the amount of inertia you can generate in a spin. So the further away the counterweights or the weight is from the center, the more inertia it has, the longer it's going to spin. All right, makes sense? So you want it as big as possible. Now, there's a downside here. So if you make this so big, when I spin it, it's going to hit the inside of my hand here. Now, some people have smaller hands, or shorter fingers, and it's going to hit inside of here. So that's something to take into account. So you could just take one, and I could just in here and try to get a diameter of this. And this one I've made a diameter of about 40 millimeters, which is fine. You can also take a look at this and take your fingers, and if you want to hold it like this or like this or like however you plan on holding this thing and spinning it, you would take this measurement and you would pinch here, and then you would slide this in and out, all right, and then try to spin it in between your fingers essentially and see what size, how big of a gap can you get here. Now for myself, I'm going to get up to about 50 millimeters, all right, for myself. If you don't have dial calipers, just use this. Take a ruler, standard inch ruler, millimeter ruler, doesn't matter, and just kind of pinch it. And then all I'm doing is I'm just going like this and spinning it. And I'm concerned about the distance from here to where my fingers are pinched. And you can see I'm spinning freely here. All right, even if I relax my hand, it's not really touching my my palm. So I can just take a look at this here, flip it around for you, and I was grabbing it about the 2-inch mark. So I can then base all of my outside diameters on 2 inches. So that's going to be the outside edge of the spinner itself, or the distance from the central point all the way out to this edge, or all the way out to this edge, or this edge. Okay. So I'm going to go with let's make one a larger one because they spin a little better. And 2 inches is about 50 millimeters, and that's about the range that I'm going to do for mine. Like I said, this little one that I have as an example has our outside radius here. Remember, we're talking about a radius because it's distance from the center to the edge. That radius rather is going to be this one's 40. So if the radius is 40, then that entire circle is 80 millimeters. Similarly, if I know that this here, I'm grabbing here at the 2-inch mark and it spins well, that from here to here, if you look at a circle, that's a radius. Therefore, my total diameter is going to be 4 inches. It's going to be that big of a circle in diameter. So what do we need to know? Well, all of our drawings we're going to base off of this, our 22 millimeters, okay? And then our outside is going to be whatever size that we determine it to be. And for me, I'm going to use 2 inches. Why not? We'll go with 2 inches in terms of a radius, or 4 inches in diameter. So now that we know all that, let's lay this out and let's go ahead and make ourselves a simple spinner. All right, just a simple little triad spinner. Everything's going to be opposed 120 degrees, and that's going to be pretty simple. All right, so let's go ahead and share my screen, and we're going to open up Autodesk Inventor. We're going to get started here. So share that, hide that, open Inventor, open up a new part file. Okay, so as we're loading this up, all right, we're going to see that this is going to take a second, because it always does. We are going to start off with our bearing has to fit inside of the spinner. So the clearance that we need, I'm not going to add any tolerances in here. I'm going to do that when I print. The surface of the bearing itself is metal, and we're using a PLA plastic. In my 3D printer, the PLA is a little bit harder than ABS plastic. A little better wear resistance, but it does wear down. Even the cheaper spinners that you'll find at like your local 7-Eleven, that sort of thing, the bearings start sliding out, and that's because you have that little bit of room where the metal is rubbing against the plastic, and obviously metal's going to rub away in plastic. Just think about a piece of sandpaper sanding that away, and that's essentially what is happening there. So we're just going to go off the exact sizes. So I'm going to start off with a new 2D sketch. And if you've been following my videos before, we always start on the XY plane, and I always start at the origin or the central axis here. And I'm going to again start with just circles. So I'm going to click the center, and I have a 22 millimeter outside diameter, and there's 22 millimeters. That works out to 0.866 or 866 thousandths of an inch is what it rounds to. But I make sure I put in 22 millimeters, and it'll automatically convert for me. The next thing that I want to do is get the diameter of the overall size, so I know my scope. I know the parameters that I need to work within, and that is going to be just another circle. Again, make sure it's concentric. If you start on the center point, it will be. And I wanted 2 inches in terms of a radius, therefore 4. Enter. 4 inches is going to be my diameter, and now I can hit the home key. When you hit the home key, it's going to zoom all the way out that way you can see everything. I'm tripping over my own words here. I was trying to find the home key on my laptop. It's not the same spot as my desktop, so that's what that was. Anyway, so all of this here, this central hole is just going to be a hole. That's where we're going to slide that bearing in. I'm going to hit escape, and I want to highlight all of this stuff here, and I'm going to make these construction lines. Okay. So up here, construction. I can also right-click construction line. Why am I making these a construction line? Because this is just what I'm going to be using as a basis. So this is my guideline. I'm going to use these in constructing my part here. The next thing that we're going to need is figuring out the size of our counterweight. Now, I would measure this, or if you're going to order them offline, you already know the distance. Well, if you're going to be using a hex nut, now the hex nuts have 6 sides, right? And these 6 sides are all flat, and they're all parallel to each other. And the only thing you really have to know is the parallel distance. Now, the parallel distance of the hex nut that I am using, since I have a pair of dial calipers here, and I can get a little bit more accurate measurement with this, and the tighter that these measurements are going to be, the better. I'm getting about 745 thousandths on my hex nut, my large I guess this must be a 3/4, a 3/4 hex nut here. So how do we do this? All right, there's something else that I'm going to want. I don't want my hex nut to be touching the edge, the outside edge of my spinner, because then there will be no material to hold that in. The general basis for a decent thickness anywhere that I found that really works is going to be a minimum of 100 thousandths. Okay, just so we can worry about wear resistance, that sort of thing. But we can kind of slide this up to the outside, just kind of do it by eye. And let's just make sure that we have something like, I don't know, 200 thousandths away, just to be extra safe, because I'm going to put a little fillet on the outside of this. And what does that mean? Well, if I take another line and I go from here and I start dragging down, now this is going to be the distance that I'm going to be using. And I want this to be 0.2. So now I'm going to hit escape, and now I have a distance of 0.2 away. And again, I'm going to right click on this time. I'm going to make that construction. Hey, construction. Construction. So now I have a construction line or a starting point. So I know that my hex nut, I want it to be 200 thousandths away to make sure I have enough wiggle room. So if I drop this on the table, it's not going to split. So now let's make our little hex. All right. So how do we make a hex? Well, a hex is a polygon. Okay. So we need a multi-sided polygon. So we need to find a polygon tool. And here's a polygon tool. It's underneath. If you have the rectangle up, it's right here. And the default is 6. Yes, I do want a 6-sided polygon. And I'm just going to click at the end of that little line I made. All right. But that's going to give me the center actually on this one. Trying to zoom in and zoom out here with my pad. All right. So if we know that we want this to be 200 away, right? And if I just click my polygon now, all right, that's going to give me a size, and that's going to be the center point of the polygon itself. All right. So I don't want that. So if I go over my polygon and I go, let's see here, circumscribed. All right. So let's make this, sorry about that. So if we start using our polygon tool, we have to decide which way we want to orient this. I'm just going to do it so the point of this edge is straight up. And so I'm going to take this, and I'm just going to drop this down anywhere. And you see all the constraints pop up. I'm going to hit escape. I said I have 745 thousandths from here to here. So 0.745. There. Okay. Now I can hit escape again, and I can just drag this over until I get it close to where I want it. And now if you zoom in, okay, I can make a coincident constraint here to there. And there we go. And now I have the base of my spinner. And I know I have a 200 thousandths gap. Okay. And let me zoom back out here. Good to go. So now I know that my nut is going to fit. And since it is a 6-sided polygon, all of the sides are going to be equal. So I know that my nut's going to fit perfectly in there. Now here's going to come the hard part. I know that I want to have something here that is 200 thousandths away from all sides. So I'm going to take, how do I want to do this? Well, there's multiple ways to do this, actually. You can start off by taking this line and making it, say, straight up and down, and making this just 200 thousandths away. All right, from right here, if I want. So it doesn't really matter the length right now. I'm going to show you why in a second. So let's just make ourselves a real rough rectangle. Make sure that this attaches to here. And the way to do that, I'm going to hit escape. Make a coincident constraint there. All right. Coincident just means that they are touching. I'm going to set this distance to 0.2. Set this distance from these two things to 0.2. Okay. And now, since I kind of have the overall shape that I want here, which is pretty good, I'm going to go right-click on, let me hit escape. Oops, hit escape before you do this. Select my circle. I'm going to undo the construction line part now. And now that I have points that intersect, I can actually trim the remaining of this. Okay, so that's one way to do it if we want to do this, and you want to keep that arc. But I actually don't want to keep that arc. So what I want to do is I want to take this and actually finish it off. And I'm going to show you why in a minute. I want my outside edges to be completely round, and I don't want to have sort of to deal with this uneven shape. But again, the shape is really up to you. All right, and that's really what we want to do. So I'm going to hit escape here. Okay, and there we go. So here we have just a rectangle. And actually this one, let's see. If we do it this way, I can actually undo this circle here. Sometimes when we do these, I will cut the circle out last. But since I'm going to show you a little easier way first, and then I'll show you the more advanced way later, actually. Just made up my mind just now. Hit the home key. Finish that sketch, make a home key. And then I'm going to extrude just that geometry. Okay? I'm just going to extrude that geometry right there. When I extrude that geometry, I'm going to make that a distance of the thickness of the bearing itself, which is 7 millimeters. And then all I have to do is go ahead and do my circular pattern. And I want to circular pattern all of this. All right, and the rotational axis I want is that circle there. And I only want 3. All right, and that means it's going to be offset 120 degrees. Okay. And there's home. And now all I have to do to really finish this up, since I'm really close to this, is fillet all of these. And since these are all the same distance away, I have 745 thousandths, right? And then I also have another 200 and then another 200 here. All right, so I'm looking for the overall distance. All right, so 200 plus 200 equals 400. 400 thousandths plus 745 is 1145 thousandths. So that's 1145 thousandths, right? And that's going to be the entire distance. But I want that divided by 2. Okay. And how I got that was I added up all these distances in here together. Okay. So you have 200 plus 745 plus 200, and you got 1.145, and then divided by 2 because I'm putting a radius on these. And now these radii on this corner and this corner will match up exactly. And now I have a smooth curve. And if you didn't want to do the math, you could have just left that curve from the original circle, but then you would have had sort of this like awkward transition from the straight to the edge. So this is just a cleaner way of doing it. And remember, anytime you have any of these things here, you're going to want to go ahead and fillet the inside here too, because you see how that looks? So if we go and grab this again, and we just repeat these fillets here, okay? And let me grab the inside of that. Now, all of those fillets will match. All right? And you can see that right now, just by looking at the size of this, it's bigger than my example, as it was, because I used 2 inches for my diameter. And on my example, I only used 40 millimeters for my radius, which would have been 80 millimeters total, which is less than 2 inches. And we always have to finish this off. Make sure we fillet all of our surfaces. Okay, so I'm going to fillet the front and the back surface. And let's look at 50 thousandths, see what that looks like. 75 thousandths too much? Now let's go with 75 thousandths there. All right, so that way we get a nice rounded edge. If you want a perfectly smooth round over, all right, you can see how I have a flat here. We can see is if we don't interfere, if it was a thickness of 7 millimeters, we can say, oops, 7 millimeters divided by 2. See, so 7 millimeters divided by 2, and now look at that, I have a perfectly smooth round over here. And since I did a 200 millimeters away, you can see I actually have space here, so the hole for this is not actually touching. It works out very well. Also, because we have to slide in the nuts and the bearing as well, it also makes sense to put a very small fillet over here as well. And the small fillet, I would say, is like, I don't know, I'd say 10 thousandths, yeah, about 10 thousandths, so 0.01. And you can see it's just the tiniest fillet, and that's going to allow us to slide in all of these surfaces here, okay? And so, and I actually canceled that one. But let me go back and do that again. Fillet, because I clicked on something else that I didn't want to click on. Click OK. And then you can go ahead and do this for all of the surfaces too. You can do it for these surfaces here as well. But the nuts actually that I have, they're rounded over at the corner, so they will already slide in. So I don't have to fillet that. They're already sort of filleted on the nut itself. But if yours have crisp corners or crisp edges like the bearing does, you might want to fillet that as well. And like I said, just 0.01 10 thousandths is going to be enough to let you slide that in there without giving you any sort of trouble. And so there you have it. Here is a large fidget spinner done. All right. And all we have to do to finish this up, besides saving it, all right, so we have to save it somewhere and call it mic test spinner. All right, and I don't want to put that in my main train. I'll stick it on my desktop, which is a very poor idea, but all right, you want to make sure it's in your proper folder. And the last thing that you need to remember to do, is to export CAD format, and you want to export an STL or a stereolithograph file. So export a stereolithograph, which is going to allow us to open this up in the MakerBot software itself, so we can go ahead and 3D print. So again, same name, testspinner.stl, save that, and then you are good to go to the 3D printer. All right, so this was just our overview of our basic spinner. We'll still have to come back and make the spinner caps, and I could talk about some more advanced designs later as well. So hopefully this was helpful for all of you, and I will see you next time.